Your house is warm because the power is on. But the moment it goes off, during a winter storm, a grid failure, or a fuel shortage, the temperature inside begins falling almost immediately. Within 6 hours, your pipes freeze. Within 24 hours, the house becomes unlivable. And this is not happening in the Arctic. It is happening in modern suburban homes built with insulation, central heating, and technology Vikings never had. Now, rewind 1,000 years. Viking families endured winters colder, longer, and darker than anything most people experience today. No glass windows, no chimneys, no radiators humming beneath the floor. And yet, their homes stayed warm enough for people, animals, and entire households to survive year after year without ever freezing. That should make you stop and ask an uncomfortable question. Because if warmth was simply about producing more heat, Viking homes should have failed spectacularly. But they did not. And if modern homes were truly advanced, they should not freeze the moment electricity disappears. But they do, often in less time than it takes to watch a movie. So how did Viking homes hold onto heat while ours lets it escape, the moment we stop fighting to keep it in? If you are interested in how older systems solved problems we still struggle with today, subscribe, and let us begin not in the past, but in the present. Modern houses are built around one simple assumption. If it gets cold, you turn something on. Heat becomes something you generate on demand. A furnace ignites, a thermostat clicks, warm air pushes through ducts, and comfort returns within minutes. Because of that assumption, everything else becomes secondary. Walls can be thin because the furnace will compensate. Open floor plans can leak air because the system will replace it. Large windows can bleed warmth all night because you will just crank the heat higher. Viking builders never had that luxury, and that constraint forced them to think differently. Fuel was scarce, and gathering firewood took days of hard labor. In many regions, trees were rare or non-existent. Burning more fuel was not a solution. It was a liability that could mean freezing later when stocks ran out. So instead of asking how to produce more heat, they asked a fundamentally different question. How do we make the heat we already have last? That single shift in thinking changed everything about how they built. For Vikings, winter was not an interruption to normal life. It was the baseline reality. Cold dominated most of the year, not just a few harsh months, and that reality shaped how homes were built from the foundation up. A Viking house was not designed for comfort first and survival second. Survival came first, and comfort emerged as a byproduct of design that worked. They assumed heat was precious, something to be protected once created. Every decision followed that logic. The house was treated as a system designed to slow heat loss at every stage. Heat was not expected to circulate freely throughout the structure. It was expected to stay put where it was generated. This is where modern thinking diverges sharply from ancient practice. Today, we build houses that leak warmth constantly and rely on machines to correct the mistake. Vikings built homes that resisted loss before fire was ever lit. Fire added warmth, but it was never the foundation of the system. The foundation was restraint, control, and thermal mass. Once you understand that mindset, Viking homes stop looking primitive and start looking intentional. And that intention shows up most clearly in what they chose to build with. Viking homes stayed warm because they were built from the ground itself. In Scandinavia, Iceland, and across the North Atlantic, timber was often scarce and unreliable. Trees grew slowly in harsh climates, and cutting them down for thick walls made little sense when winter returned, without fail every year. So Viking builders turned to what was abundant and already adapted to cold: earth. Walls were constructed from heavy blocks of turf cut directly from the soil, layered with roots and compacted grass still woven through them. These walls could exceed 1 meter thick at the base, narrowing as they rose. This was not crude construction. It was a thermal strategy based on understanding how materials behave. Soil traps air in countless tiny pockets, and still air is one of the most effective insulators known to physics. Inside those turf walls were millions of microscopic air chambers that slowed heat transfer dramatically. Once warmth entered the house, it did not rush back out. It lingered, held in place by the very structure. But the mass of those walls mattered just as much as their insulation properties. Thick earth absorbed heat from fires, bodies, and animals during active hours, then released it slowly through the night when temperatures dropped. Temperature swings were softened rather than amplified. Cold snaps were delayed by hours or even days. The house functioned like a thermal reservoir, storing energy when it was abundant and releasing it when needed. Modern homes use thin layers and active systems to compensate for their lack of mass. Viking homes used mass, patience, and physics, and the walls were only the beginning. Heat was not just stored in materials, it was produced continuously by the people living inside. Viking homes were not built for privacy. They were built for survival through shared warmth. Entire families lived, worked, ate, and slept in shared spaces beneath a single roof. This wasn't crowding caused by poverty or lack of skill. It was an energy decision based on simple biology. Every human body produces roughly 100 watts of heat continuously, whether moving or at rest. By concentrating people into one enclosed volume, Viking households turned daily life itself into a steady heat source. Modern homes do the opposite. Bedrooms are isolated, living spaces are spread out, and heat is pushed down long corridors into empty rooms, then lost through walls and windows no one is using. Activity was also concentrated around the hearth. Meals were prepared and eaten in the warmest zone. Sleeping areas were positioned where rising heat naturally collected. Even rest was organized around retaining warmth rather than personal space. Heat wasn't generated in one place and expected to travel everywhere. It was allowed to gather, layer, and remain exactly where people actually lived. But humans were only part of the equation, and to truly understand why Viking homes stayed warm, you have to look at what else shared that space during winter, because the most powerful heat source in the house was alive. During the coldest months, Viking homes were shared with animals. Cows, sheep, goats, and sometimes horses were brought indoors and housed within the same long structure. To modernize, this looks primitive or unhygienic. To Vikings, it was efficient energy management. A single cow produces roughly 1,500 watts of heat continuously, equivalent to running multiple electric heaters around the clock without consuming any fuel. Multiply that by a small herd, and you have a reliable, steady warmth source that never needs to be switched on. This heat was not wasted through poor design. Viking homes were shaped to guide it. Livestock areas were set slightly lower than human living spaces, and warm air naturally rose, flowing upward into areas where people gathered and slept. No pipes, no fans, no mechanical systems, just gravity and intentional design doing the work. The animals stayed warmer, the people stayed warmer, and fuel use dropped dramatically compared to what would have been needed otherwise. Modern homes separate life into sealed compartments, then burn energy trying to replace what that separation loses. Viking homes shared warmth across living systems that already existed, but even with bodies and animals producing heat, there was still a major threat to overcome. Cold on its own rarely drains warmth from a house. Moving air does. Viking builders understood this instinctively. A calm, freezing night could be endured. A windy one could strip heat from bodies and walls faster than fire could replace it. So their homes were designed first and foremost to control airflow and prevent drafts. Openings were treated as weaknesses. Windows were rare or non-existent, not because Vikings lacked skill, but because every hole was an invitation for heat to escape. Darkness was accepted as safer than drafts. Walls were sealed tightly, gaps were filled with moss or clay, and nothing was left to chance. Entrances were kept low and narrow, forcing anyone entering to crouch. This was not symbolic. It reduced the volume of cold air that could rush inside. Many homes added short entrance passages that acted as airlocks, trapping cold air before it reached the living space. Inside, the goal was stillness. Air was allowed to move only where it served a purpose. Heat rose and stayed where people slept. Cold air sank and remained near the floor where it caused the least discomfort. Modern homes prioritize airflow for comfort and air quality, then spend enormous energy correcting the heat loss that airflow creates. Viking homes accepted stillness and darkness in exchange for warmth. That control of air led to a design choice that seems dangerous by modern standards. They kept the smoke inside. At the center of a Viking home burned a fire that behaved nothing like a modern fireplace. It was not tucked against a wall, and it was not connected to a chimney pulling warm air straight outside. It ran through the middle of the house, long and low, built directly into stone and earth. This fire was designed to burn slowly and steadily, not hot and fast. Smoke did not vanish. It rose, spread, and settled beneath the roof, forming a warm layer above the living space. That layer acted like an invisible ceiling, trapping heat below and preventing it from escaping upward. Warmth stayed exactly where people lived and slept. They allowed the house to breathe just enough to prevent suffocation, but never enough to waste heat. Small roof vents could be opened or closed depending on conditions, and in winter, they stayed nearly shut. The smoke also did something else unexpected. It coated beams and timbers with soot, slowing rot, repelling insects, and drying the interior over time. The house preserved itself from the inside out. Modern homes remove smoke immediately, and they lose significant heat with it. Viking homes accepted smoke as part of the system, trading comfort for survival. Above that smoky layer sat another critical element that most people overlook. A Viking roof was not a thin barrier meant only to keep out rain. It was thermal mass. Layers of birch bark were laid down first to create a waterproof skin. On top of that, thick slabs of turf were stacked and compressed under their own weight. When finished, the roof could weigh several tons. That weight was not a floor. It was insulation and a thermal battery combined. The heavy roof slowed heat loss dramatically. Warm air rising from the hearth met resistance instead of easy escape. The temperature inside changed slowly, not suddenly. Daytime warmth lingered deep into the night. Cold snaps took hours or days to penetrate, rather than minutes. Over time, grass grew across the roof. Roots locked layers together, sealing gaps and protecting the bark beneath from wind and water. The roof literally repaired itself by being left alone. Modern roofs are light and efficient at shedding water, but they lose heat quickly and depend on active systems to compensate. Viking roofs relied on mass, moisture control, and time. When winter storms arrived, the Vikings did not rush outside to clear snow away. They let it stay because they understood something we often forget. Snow is not the enemy. Snow looks hostile, but thermally it is protective. Fresh snow traps enormous amounts of still air between its crystals. That trapped air slows heat transfer so effectively that snow has been used as insulation by Arctic cultures for thousands of years. Vikings understood this through experience, not equations. As snow piled against longhouse walls and settled onto turf roofs, it sealed gaps, blocked wind, and stabilized temperatures. What looked like burial from outside was actually reinforcement. The house became wrapped in an insulating shell that softened temperature swings and reduced exposure to brutal winter gusts. Entire villages could disappear beneath snowdrifts, leaving only doorways and thin trails of smoke visible. Inside, temperatures near the walls hovered far closer to freezing than to the deadly cold outside. That difference was the line between endurance and disaster. They did not fight winter head-on. They let winter help them. Which brings us to the real reason Viking homes stayed warm. Not a single clever trick, but a system where every element worked together. Viking homes stayed warm because nothing was designed in isolation. Walls, roof, fire, animals, people, airflow, and even snow all functioned as a single integrated system. Heat was never expected to solve problems alone. It was supported, protected, and reused at every stage. Loss was slowed before more warmth was ever added. Modern homes reverse that logic completely. Suburban houses are built to be open, bright, and segmented. Rooms are separated by long hallways. Ceilings are high and vaulted. Windows are large and numerous. Air moves freely throughout. Heat is expected to be produced endlessly to compensate for all that exposure. When energy flows, the system works beautifully. When it stops, the illusion collapses in hours. Viking homes were resilient because they did not depend on constant input. If the fire burned lower, the walls still held warmth. If fuel ran low, bodies and animals still produced heat. If storms raged outside, snow reinforced the structure instead of threatening it. This was not primitive living. It was layered redundancy, where multiple systems backed each other up. Modern housing is efficient on paper, but fragile under stress. Viking housing was inefficient by modern metrics, but durable when conditions turned hostile. That difference reveals something uncomfortable about what we have built. We did not necessarily create better homes. We created homes that assume everything will always work. One final question is worth asking. What happens when it does not? Viking homes did not survive winter by overpowering it. They survived by understanding it. Their homes functioned even when conditions were worst. Built not for convenience, but for continuity. This is not an argument to abandon modern life or to live under turf roofs again. It is a reminder that resilience comes from design that assumes failure is possible, from systems that hold together when inputs drop. If you're interested in the practical wisdom buried in history and what it still teaches about building lives that don't collapse under pressure, subscribe and stay curious, because the question isn't whether we're more advanced, it's whether we're more prepared.